So yeah, so we'll continue with these notebook from the GitHub. It's the one, yeah, this is the one. The three GitHubs. One is the Qiskit algorithm. The other is the Qiskit machine learning, and the final one is Qiskit-Nature. It's impossible for me to cover everything, so I have to select. But these could be options that you can make for your final presentation. So I have some slide from the previous, but the application, you could apply this variational circuit to like optimization problem like max cut. Basically, you want to cut into two different groups and maximize the weight or minimize, it depends. Yeah. So this is just one example. And there's also other optimization problem, maximal independent set, others. And I think we discussed the QLA algorithm. This is used to maximize this max cut and max reset. So I'm not going to detail just to show the applications, right? And then I list these all the tutorial from this Qiskit algorithm. Right, there are 13 of them. I plan to cover maybe the variational quantum imaginary time or real-time evolution. This one here. And there's machine learning, but we don't have time to cover the classical machine learning. But the idea is sort of neuron, you have some input and output. And this is modeled as some weight, right? Weight linking one neuron to another. So it'll be a matrix. It's like the matrix that connects to that. And each neuron itself also have some activation function. It depends on what you choose. Like this one here, we usually call it sigmoid function. It's like Fermi-Dirac distribution. Yeah. And then you connect all these neurons. So basically, classical neural network would be a bunch of weights, bunch of nodes that has some thresholds, some B. Here it's called bias, and then you have some weight, and this outcome would be the input for this weight matrix, and that yeah. So this is from the previous. For example, here, let me say the X input here, and then times the weight, and this one here has a bias, and it would activate according to this sigma. Okay, but this is really really brief overview, just 10 seconds or 1 minute overview of the classical neural network. Okay, I think they are experts in the audience. And the nice thing is you can use gradient descent to do the optimization, and there's a back propagations, a lot of technique that enable efficient evaluation. So I'm not going to the detail. Yeah, so it's not essential because what we're going to use is really using quantum circuit. We're not exactly using the classical weight matrix and bias. Okay, so there are other ways, other neural network, sort of convolutional neural network. It involves maybe processing images, and you have different property, and you would do some coarse graining, as illustrated here. But this really, I'm going this very quickly, partly because we don't exactly use it, and also partly because I'm not an expert on this. So this is how we're going to use you may use a classical neural network as an input to your quantum, or you just entirely quantum. And then you could also output from the quantum circuit to classical neural network. So it could be the hybrid. Yeah. So in that folder, Qiskit-Machine-Learning, there are, you see here, including these 2A, so there will be 14 tutorial. This is the snapshot I took a few months ago. So this update will be maybe 4 months ago. I would be I'm thinking this tool here, neural network classifier and regressor, and then quantum kernel here. So today I'm just serving as an overview of what I would be talking about. Okay. And then it's also application to molecules, the ground states, depending on the atomic distance. This is more of the application to chemistry. So you can apply the quantum method to simulating molecular energy. Mostly still done with the variational quantum circuit. Yeah. So for this, you probably need to know about some orbital. It's shown here. And you learn it in chemistry, maybe high school already, and maybe college chemistry. You have the orbital and you feel electrons up and down, etc. And you need to write a Hamiltonian that govern the system, and we would use in second quantized form. I'm not going to the detail. We've seen these operator, right? A dagger, A, C dagger in the previous course on QoS. Yeah, so it's basically like that. The second quantized form is talking about the electron, and these alpha beta are the label of the orbital. So you would annihilate from one orbital and then create to the other one. It's representing the hopping. And this alpha beta could be real space or it could be momentum. And this here, C dagger, CC represent interaction. So you need to have these coefficient computed from some other method, and mostly using classical method to compute these coefficient. And then you put this Hamiltonian on quantum computer. But this is a fermionic. In order to put it on quantum computer, you also need to do transformation from fermion to spin. There are a few options. The most well-known is the so-called Jordan-Wigner transformation. Yeah, this shows the expression, but this will be computed from the software. For example, the Python has these PySCF package that would take care of these. Yeah. So I'm not going to go into the detail, but this could be the final project presentation if anyone is interested. Yeah, and by the way, anyone who is not taking this course formally, you could also submit a recorded video if you want, and I'll make the video available to everyone to watch. Okay, so I'm not going to the detail. This is just Jordan-Wigner from fermion to spin. There's also other encoding. Okay. There's some, yeah, in the past, I did this also. I did this in my QoS course. In the earlier version, I talk about this one, and I did this demo on the lithium hydride molecule, lithium hydrogen. Yeah, so this is the example from IBM's results a few years ago, quite a few years ago. And just to show that this is the sort of exact solution under that approximation of the Hamiltonian. And these are data point. And the blue dot represent the extrapolated result. with error mitigation. So with mitigation, you can get very good result, but without mitigation, the results are not so good. Okay, this is just showing the error, like milli-Hartree. Milli-Hartree is probably the gold standard of the chemistry accuracy.
Are those data points different noise levels?
Yeah, they can control the pulse shape of their device.
Extrapolating only from 1 to 1.5?
This to that, yeah, 1.1, 1.251. So this is the amplification scale. Yeah. Okay. So I hope that this is give you a good overview of what quantum computer can be useful. So, and in this Qiskit-Nature GitHub, there are 12 notebook. I have not decided which one I will cover. Yeah, there are so many material that we can cover, but that means there are also many options for you. So basically, this is my plane, and I think we don't have enough time to cover, but I want to show you that, I mean, these are from the GitHub. So in order to run, you need to install the package. You need to install. So maybe, for example, there will be description if you go. I'll make the slides available. So Qiskit algorithm, we have discussed that quite early in the lectures. I'm just seeing the update here. This last year. So want to point out Qiskit algorithm does not have the estimator V2 or sampler V2. So that's means that it at the moment it cannot directly submit the job. You need to update the estimator, the primitive class. So that's one drawback here, but I think people would update. But it is has not there's nothing been done yet. Okay, but you would need to install this. Really just using pip install should be right. Pip install Qiskit dash algorithms. So it would handle the dependencies. Okay. So this is the one, and the other two are similar. So if you go to the maybe I think I paste the link, but for those who came later, let me see. I could just copy the link. Okay, let me paste the link again because if you came in later, you won't see the link. This is for the algorithm. And let me go to the other, which is machine learning. Okay. Oh, let me share the screen. Yeah, I think I did not show the screen Qiskit algorithm, but it's similar. The installation, you can see that. Yeah, here you would use pip install Qiskit dash machine dash learning to install that because there are built-in packages that facilitate the running of machine learning. Yeah. And the final one, let me copy this to the chat. I was planning to go through one notebook today, but I it's okay. We went through the lab slowly and then review some of the earlier stuff by just playing with the code, which is fine. The last one is Qiskit-Nature. Okay, let me copy. Okay, it's taking you to the tutorial. So the tutorial is under the document and tutorial. Okay. What I basically did is I just clone it, and under my folder I have all these Qiskit algorithm, Qiskit machine, and Qiskit nature. So basically I have to clone that under this folder here. And if I want to access the tutorial, I need to go to document and tutorial. These that I assign P is what I plan to cover, but maybe covering 3 would also be too much. So I probably will settle with 2 on each. Okay. Any questions? So these are, yeah, this Qiskit algorithm, Qiskit machine learning. This is Qiskit nature. Let me go to the front page. Installation is similar. Just okay. Really just pip install Qiskit-Nature. Yeah. There are a lot of materials. And you could one day it might be Qiskit other things, right? Other applications. Maybe one day it will be Qiskit biology or something. Um, Qiskit gaming or Qiskit finance. Yeah. So I think we're toward the end, but I'm just showing you our course website. It's not this one. Where's okay, let me this website just to see our progress. Right. So we're done with these. So I'll be covering okay, this week 10. We are actually at week 11. So we have maybe just 1 week or 1 week and a half to cover these 3 different, maybe 3 lectures. I could each choose 2 from each. So I can cover this. And the Q-tip, we have 3 lectures. Actually, I am going to a conference next Monday. I have not 100% decided if I do go, then I will record video. And then that will probably be Penny Lane. So maybe we will be left with 2 lectures or 3, maybe 3. It depends on the progress. But I think we could probably go slightly faster than usual because you guys have known these methods already, and it's really just applications. So I will see because I really want to give some introduction to Q-tip. And so I will not have presentation in class. The final presentation will not be in class, will be recorded. So then I have more time to cover material. Yeah. Okay. So, but you should start thinking about what the project you want to cover. As I go through these 3 different GitHub, then you will probably start thinking about what you cover. And then in my recorded Penny, then you can start thinking about maybe you also want present demo from Pennyland. Yeah, so there are a lot of options. Yeah. Okay, any questions? We won't have final exam, so that the final will be you record your video and submit that maybe before the final exam day. Okay, so that's it for today.